Let's start talking about Chebyshev's theorem. This is probably one of the first concepts in Introduction to Statistics that is confusing for most students. And I think the best way to explain it is to explain it in relation to the empirical rule. So the empirical rule is a rule that works in a very singular situation. That situation is when your data looks like this. So your data is perfectly normal. It is bell-shaped, looks like a bell. And what the empirical rule says is that, so if your data is shaped like this, then within one standard deviation, you are going to have 68% of your data. And then within two standard deviations, you are going to have 95% of your data. And then within three standard deviations, you are going to have 99.7% of your data. This is all well and good, but what about the situation that happens way more often in real life where your data doesn't look like this? So it's not bell-shaped. So maybe your data looks something more like this, right? So you've got two bells and neither of them are the same shape. So maybe your mean is somewhere around like right here. And then, your standard deviations, if you go out, look something like this. Then while the empirical rule might approximate what you need, chances are that within this area, you don't have exactly 68%. And so that's what the Chebyshev's theorem is made to address. Chebyshev states that for any set of data, no matter where that data comes from, that the following rule applies. At least 1 minus 1 over k squared of your data will lie within k standard deviations of the mean. So at least 1 minus 1 over k squared of your data will lie within k standard deviations of the mean.